going to do 5.4 today, systems of nonlinear equations in two variables. So the linear equations, how do I know something's linear? By looking at the equation? That's the graph of it. By looking at the graph, I know that. But if I'm just looking at the equation, how do I know that that equation has a graph that's linear, or that's a line? That's right. I don't have any variables raised to any power other than 1. Okay, so what's going to happen here is that you're going to have some that are nonlinear. So you may have some things that are squared or raised to the 3rd power or something else. So we've got to talk about how to do those two things. First thing I want you to be able to do is actually be able to recognize the systems. Again, like I say, you're going to be looking for things that actually don't, that there's a variable that has an exponent. Okay, that's how you recognize it. There's a couple of ways to do it. Most of the time, you use substitution. Every now and then, if you have a real special situation, you can actually use elimination that we talked about last time. But most of the time, you're going to have to do substitution with these. Check point 1. So I've got x squared is equal to y minus 1, and 4x minus y is equal to negative 1. As you can see, I can't line it up, right, because I don't have an x squared term to go with another x squared term. I don't have an x to the 1st power to go with another one. So the best way to do these is by substitution. Now, this is already solved for x squared, but do I have an x squared in the other equation to plug it into? No. So I can't leave it like this. But what I can do is I can take this equation and solve it for y, right? So if I had x squared plus 1, that's the same equation as x squared is equal to y minus 1. Now I can take that expression that I just came up with for y and plug it into my second equation. So I have 4x minus x squared plus 1 equals negative 1. And don't forget, anytime you're doing substitution, put parentheses around what you're substituting in so it makes it easier for you to see what you're doing. That way you won't lose signs. Okay? So I just took everything in this second equation and wrote it down, but where the y was, I replaced it with the expression from the first equation. Everybody see that? Now, when I subtract this off, means I got to actually distribute this negative sign through that parentheses, right? So this becomes 4x minus x squared minus 1 equals negative 1. And if you have an equation that looks like this, what do you have to do? How do you solve this? Got it. You got to put it in quadratic form. I need it set equal to 0, right? So I've got 4x minus x squared, and I'm adding 1 to both sides. So that's a 0 pair on both sides, so that's equal to 0. Everybody see what I just did? Now, when I get this doesn't factor with two binomials. How does this factor? These are the ones that y'all hate. Y'all always forget to do this first. I always tell you to look for this first. Factor out a common factor, the x. So if we're going to factor out the x, and what's left in this first term? 4 minus, and what's left in the second term? The x. Always, if there's just two terms, look to see if you can factor out a common factor. And then, now that I've got this in factored form, I can take each piece and set it equal to 0. So x is 0, and 4 minus x is equal to 0. Each one of the factors gets set equal to 0. Because if I have two things multiplied together and it's equal to 0, then one of them had to be 0, right? It's the only way it happens. So I've got x is 0. If I subtract 4 from both sides, I get negative x is equal to negative 4, so x is equal to positive 2. So I have two different x values. Yeah. Positive 4, what I wrote, but not what I said. Okie dokie. So what do I have to do when I have a system of equations? I need a point, right? I want the intersection point. So I have some x values. I have x is 0, and I have x is equal to positive 4. What do I have to do? Find the y to go with each x, right? So I've got to plug them back in. Doesn't matter which one you pick. You can plug them into the line or into the parabola, right? That is a parabola, isn't it? Yes? So if x is 0, then y is equal to 0 squared plus 1, which is 1. And y is equal to 4 squared plus 1, which is 17. So I have two pairs, or 2 points, that both together form my solution. Now, we said we couldn't have two solutions before. Why is this different? Let's think about it for a second. What's going on right here? That's a what? A parabola that's been moved up one, right? Yes? What's this right here? A line. So that's going to give me negative y is equal to negative 4x minus 1. So y is equal to 4x plus 1. That means I go up to 1, and I go up 4, and over 1, and there's my line. So, can you see what's going on here? I'm going to cross at this point 0, 1. I can actually see that. But if I extended, if I hadn't drawn the graph at the top of the paper, I might could extend it out enough. On the top of the board, not the top of the paper. But it'll also cross at 417. Everybody, because it's a line and a curve, so it will come back. One of them does curve back around and come and touch it again. Y'all understand? So on these, with these different types of equations, we're going to have more than one solution a lot of times. Not every time. But if I take two circles and I intersect them, how many points could I possibly be touching in? Maybe not two circles. Maybe a ellipse and a circle. If I had a circle and it intersected with an ellipse, I could actually touch it in 4 different places, or a parabola, a circle and a parabola. Right. Can you see how you could have up to 4 different solutions there? But a line and parabola is not going to have more than 2, right? It could have 1, or it could have 0. The line could actually go across below the parabola. So you've got all the same types of situations that you had before, but we just got a possibility of more solutions, depending on what your shape is. Any questions about that? So anytime you've got this thing going where it's 2 different kinds of shapes, you're most of the time going to have to do substitution. That's the one you're going to see most often. Occasionally, we do have a situation where we can use the elimination method. Okay, so let's talk about the elimination method, or the addition method. That's in special cases. Let's look at our checkpoint 3. We got 3x squared plus 2y squared is equal to 35. And 4x squared plus 3y squared is equal to 48. Now, does anybody remember from last year? So actually, those are not circles. Because why? Well, the x squared and the y is squared, so it's close to a circle. But why is it not a circle? These coefficients right here are not the same. When the coefficients are different, it's actually an ellipse. It kind of like makes it longer, an oval. Yeah, an ellipse. Okay, so if these were the same numbers and it was a plus sign between them, and they're both positive, it would be a circle. Okay? You'll kind of remember that. That's a hyperbola. You don't remember hyperbolas from last year? Hyperbola looked like that. Remember that? And the way it either looks like that or it looks like this, and remember the way you decided is which one was negative. But one was always negative and one was always positive. Okay? So just looking at an equation, you can tell what the shape is. You might not be able to draw it, but you can tell what the shape's going to be based on what variables and what power they are and what their coefficients look like. Okay, so since both of these are squared, and since the coefficients are different and they're both positive, this is an ellipse. Not exactly sure where the thing lives, but I know it's an ellipse. Okay? Any questions? All right, well, let's see. Do you see why I said I could do this one by elimination? Because the only x's I have there are both x squares, and the y's are both y squares. So you can see that I could actually get a zero pair, right, because I got nothing but like terms. Don't have anything extra hanging off there that's going to mess me up. Now, it doesn't really matter which one y'all want to get rid of, the x squared or the y squared. The x squared. So let's multiply through by negative 4 and a positive 3, because 3 and 4 don't have anything in common, so all I can do is swap them. So I've got negative 12x squared minus 8y squared is equal to, what will that be, negative 140? 4 times 35? Can't end it. Okay. All right. I said I can't end in a 6. All right. So we got 12x squared plus 9y squared is equal to 144. And we add. So this is our zero pair. It's gone. I've got a positive, 1y squared, right? And that's equal to 4. So y is equal to the square root of that. And it's a positive and negative. Don't forget you always get a positive and a negative value when you take the square root to solve something. The square root wasn't already there and you put it on there. You got to take positive and negative values. So y is equal to a positive 2 and a negative 2. Then what do you have to do? On these, sometimes it's easier not to plug it in. Sometimes it's easier just to go back and redo an elimination method and get rid of the y's this time. Just up to you. I think it's easier to go back and do the elimination method, and then instead of multiplying by negative 4 and positive 3, you multiply by 3 and negative 2. So I can get rid of the y's. So I get 9x squared plus 6y squared is equal to 105. And negative 8x squared minus 6y squared is equal to negative 96. So my zero pair this time is the y. So I get x squared is equal to, what is that equal to? Did I mess up? Yeah, minus 6y. 3 times 35 is 105, and 2 times 48 is? Okay, so 105 minus 96 is what? 9? Okay, I was thinking it was 19. I forgot to carry. All right, so x squared is equal to 9, so x is plus and minus the square root of 9, which is plus or minus 3. So, positive 2, positive 3, positive 2, negative 3, negative 2, positive 3, and negative 2, negative 3 are my 4 solutions. Because you had 2 ellipses intersecting, so 4 solutions. it's not hard. It's just different. You got to pay attention to those squares. And you got to remember when you take the square root to solve it, you get a positive and a negative value. Okay? Anything else? Well, let's do checkpoint 4. On checkpoint 4, it says we've got y is equal to x squared plus 5. And x squared plus y squared is equal to 25. Okay, so let's talk about what those shapes are just by looking at the graph. Looking at the equation. What does the graph look like? What's the top one? It is a parabola because just one of the terms is squared and the other one's linear. And then what's on the bottom equation? What is that? That's a circle because it's plus. Both of them are positive and they have the same coefficient. Okay? So I've got a parabola, and a circle, so I could have up to 4 solutions, right? All right, so can I do this one with the elimination method? No, because I don't have the same. I've got an x squared that's in common to both of them, but my y squareds are different. I can't, but then I'd get up to, I'd have an x to the 4th. So I'm just making it worse. So that's why I say most of the time if you have different shapes, you're going to be using substitution. So what you're going to do is you're going to take this expression that y is equal to and put it in for y in the second one. So I have x squared plus 5 squared equals 25. Uh-oh, it's right. So I'm thinking that's not a good plan. We don't want an x to the 4th, right? Yeah, you really can't. Okay. But what I could do is I could notice, put it in the wrong slot. I said x squared plus what? I do have an x squared, right? So if I take this one, I could make this x squared is equal to y minus 5. Right? Then where this x squared is, I could just replace it with y minus 5. I'm being sneaky, so I have less work. Okay? I took this equation, and I solved it for the x squared. See it? I subtracted the 5 and put it up there with the y. Okay? Then I took that and I said, well, if y squared is equal to this, then I'm going to replace the x. If x squared is equal to this, then I'm going to replace the x squared with just y minus 5. It's not squared anymore because x squared is equal to y minus 5. You understand? I don't have to square it anymore, so that takes care of that whole having to do the full. So look for ways to make your life easier when you're doing this substitution. It would have worked the other way, but it would have been a whole lot more work. Okay? You ready? So you ready for this now? Okay. So what do I have to do to solve this? I can just drop it off, right? So I've got y minus 5. Thank you. Okay, so y minus 5 plus y squared is equal to 25. Now what do I need to do? Are you sure you want to add 5? We need to subtract 25 because what do I need to do? Get it equal to 0. Put it in quadratic form. So I'm going to subtract 25 from both sides. So I've got y minus 30 plus y squared is equal to 0. CJ, what were you going to say? Put the y squared in front because we don't like it like this. You can't factor it. So we got y squared plus y minus 30 equals 0. And now this is one that factors nicely, right? What two things multiplied together give you negative 30 that add together to give you positive 1? 5 and 6. So y minus 6 plus 6, y minus 5 equals 0. So you get y is equal to negative 6 and y is equal to 5. Okay? Any questions? Now I got to go back and plug it in. And I have this equation that says y is equal to, or I guess I don't want that. Let's use it in the form where it's already solved. X squared is equal to y minus 5, right? We already solved it for x squared. So x squared is equal to negative 6. Oh, can x squared be equal to negative 6 minus 5? Is it going to give me a real number answer? It's going to be imaginary, and I want my real answers. I want the place where it actually crosses. So why might, with the negative 6, does not give me a solution that I can use? Well, it'll not work. So x squared is equal to 5 minus 5, which is 0. So x is equal to 0. So in this case, even though I've got a circle and a parabola, it's only actually going to touch in one spot. Oh, my goodness. You are so very, very right. Nah, not everywhere, but a lot. That's the end of that problem. Okay. All right. So any questions about that? That's one problem. I told you these problems are long. They are easy but long, that is right. But I will tell you this, in Chapter 6 we do learn a shortcut on how to solve linear equations, but there are no shortcuts to solving these nonlinear equations. You absolutely just have to do them. So this is one section that I'm going to say it's worth your time to learn how to do this because it's the only way to be able to do this. Your homework, there is one more checkpoint in there. That's on an application problem, but you're just going to set the equation up, then do the process on it, so it's not a big deal. Okay, so your homework is on page 534, 4 through 60, multiples of 4.